So example 3, quiet please. Find the missing term in the geometric sequence, right? So again, we would take the geometric mean, right? You go the square root of 20 times 80. Which is the square root of 1600. Which is 40. So if that's a geometric sequence, what's R? Yeah, looks like you're timesing times 2, right? Times 2, times 2, times 2. We get that? And not a hard calculation, not one you might have known of before, but not a hard calculation. But it would not have been, we were told it was a geometric, so we had to do that. Yeah. The cube root of 8? Why is that? So why 8? Okay, quiet please, too loud. I'm not quite seeing your logic behind picking 8, but I mean you can do things like instead of doing this, I mean this works for this one, but what if it was like 3 or 4 or 5 missing terms? I mean, for example, what if I had A2 equals 1 and A9, is it? No, 8 equals 64. Find R. Well, if it's a geometric sequence, you would say, well, how many times would I have to multiply times R to go from the second term to the 8th term? 6 times, right? To go from the second to the third, you do once. From the third to the fourth, you do again. So all the way from the second to the 8th is 6 times, right? So you would write A2 times R to the 6th equals A8. And since you know the A2 and you know the A8, you solve for that, right? You plug them in, A1, A2 is 1, if I don't write that. R to the 6th equals 64, and then you take the 6th root, and that's 2. So that way you could fill in as many spaces as you need, you could fill them in then, because you got the R. But that's not what we're doing. We're doing this.